To combine functions, what we want to look at are a few things. So we want to look at, number one, the domains of the two functions being combined. We want to think about what those functions are and what they are like algebraically when we combine them. And we can also use a table of values to help us plot some points to get a pattern. So this first one here, we have a domain of x is going to be greater than or equal to not 0, but going to be greater than or equal to -3. I'm just going to zoom in a bit here. And the range, which is not as easy to analyze, but we'll just put down the range anyways. The range is going to be greater than or equal to 0. Okay, so with the domain of this function, domain and range is going to be, domain is going to be all real numbers, so there's no restrictions here. And the range is going to be all real numbers. Okay, so then when we look at the combined function of f of x times g of x, this is a square root function times a linear function. So the degree is going to be about 1.5. So it's going to behave a little bit somewhere in between a linear function and a quadratic function. So when we start plugging in some points here, making a table of values, we can start with x is -3, y is going to be 0 here times, whatever that y value is there. Okay, it's good to maybe plot x equals 0, because from this graph here, we can see that this gives us a factor of 0. So at x is 0, y is going to be 0 again. Maybe plot a point in between here, so x is -2. When x is -2, y is equal to 1. Here x is -2, just going to zoom in a bit. Y looks like it's going to be equal to -4. So we have 1 times -4 gives us -4 y coordinate. I'm just going to plug in one more here. So let's look at x is equal to 1, y is equal to 2. So at x equals 1, y equals 2 here. At x equals 1, y looks like it's equal to 2 here. Okay, so it's going to be 2 times 2, which is 4. And this should start establishing some patterning. So at -3, we've got 0. -2, we're at -4, so it goes down here, goes back up to 0. X is 1, y is 4. We know the domain is going to be the most restrictive part of this, so the domain must be x is greater than or equal to -3. And so sketching this graph, and it's going to go down. We don't exactly know where the vertex is, but it's going to go down like this. And it's going to start heading up like that. And we have no reason to believe, based on the patterning of the graphs, for this to come back down, because the y is increasing positively. The y here is increasing positively as well. We can take a look at the quotient function here, and we can do the same thing. So we have our domain. Okay, x is going to be greater than -3. We have to also consider that we're going to have a restriction on g, because g is in the denominator. Okay, we know that 0 can't work. Okay, so based on this f and g, our domain of this new function is going to be x is greater than or equal to -3, but x cannot be equal to 0, so we would expect a vertical asymptote at 0. This is a reciprocal function starting at, a rational function, so we should expect some asymptotes. We can make a table of values. We know our starting point is going to be at -3, so when we evaluate x is -3, it's going to be 0 times whatever that is, or is divided by that. It's going to give us 0 anyways. We can plug in x is maybe -2. X is -2. We have y is equal to 1. Here, -2. Y is equal to -4. So we get 1 divided by negative 4, so we get negative 1 over 4. We have an asymptote at 0. Plug in maybe x is 1, x is 1. We're going to end up with y equals 2 and 2, so 2 divided by 2 is 1. Because this is a rational function, we should think about what's happening as endpoint behavior. So if we have a square root function over a linear function, that's the numerator is less powerful than the denominator, so this is going to tend towards 0 as x goes to infinity. So we know that the limit as x goes to infinity of this f of x over g of x we're going to have a limit of 0. So we know that it has a horizontal asymptote here. We kind of would assume that's the case as well, because this is a rational function. So drawing this rational function, I've got y is 0 here, negative 2, negative a quarter, and we know that it's going to go down towards the asymptote here. X equals 1, y equals 1. There's a point here, and we know it should follow the asymptote in this manner. Okay, so that is our estimation of what this graph should look like.